by this experiment we are able to detect the heart rate using averaging and derivative filters provided 150 samples with sampling frequency of 50 Hz. And here is the code to do it in Arduino UNO. We took the 150 samples here. This is the array. We have 150 samples, and this is the code for that. Here we take n of 5, an empty array, so that we can do the moving average filter for 5 consecutive numbers, and L is 150. And in this code we are using two moving average filters. For the first moving average filter we are taking 5 consecutive values, and the second we are taking 15 consecutive values. Serial dot begin 9600 is the baud rate for this. And here is the code for first moving average filter. We are taking first 5 numbers and taking the average of them and keeping copying it in an array. This is the code for moving average filter. And next we should do the let's see the output for the first moving average filter. We can see that these are the 3 peaks which we should count, which we should consider, and these small peaks we should neglect. Still we have a peak which is over 0, so we should take off that peak. So we are doing so we are again doing a derivative filter, first order derivative filter. And here is the first order derivative filter, you can see it. And after that we are again using first moving average filter for the better uh, for the better values. So now let's take off these comments and see the output for the second moving average filter. Let's uncomment this and let's comment this to avoid overlapping of the. So let's take the output for the second moving average filter. So here we can see the 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 output for the second after doing the second moving average filter, we get the output, the red line. The red line is the plot for the after the second moving average filter. So we neglected these peaks, which are which should be so that we got only the 3 peak values above 0. Now we will calculate, we will write code for the zero crossing so that we will get the peak values, and so that we will only count these 3 peak values. So here is the code for the zero crossing. This is the code for zero crossing, and after that we will get the number of number of peak values, and that value is d, and k equal to 50 into 60 by d, so that we will get the heart rate per minute. Okay, let's see the what's the heart rate. Okay, let's close this. Serial, by opening the serial monitor will let us know the okay, we got 69. The heart rate is 69 for these samples. For the given samples the heart rate is 69. By this experiment we did moving average, how to implement moving average filter and first order derivative for the signal to find the heart rate. These filters are used to avoid the unwanted peak values, so that we will get the so that we can get the original peak values and avoid the noise.